Okay. Hello. I will talk again about the Yocto, but not really for a product, for some specific tools we can use additionally on an image. I am a CTO of Smile ECS. Smile is a French company in Paris and several towns in France and some place in Brussels. I am a teacher and long-term user of open source software. I'm a teacher, writer, and bad English speaker. This is my favorite competence. I will talk about using build system for our industrial. There was several Yocto presentations today, so I will be very quick about Yocto, about the introduction. I will try to do a demo. It will be the third demo today, and maybe the third demo will fail, or I don't know, because the two previous demos failed, so not for me, but no. The robot was broken, maybe the pie will work, I don't know. We will create a recipe, not for creating a recipe, but to use, in order to use some tools on the recipe, to modify the recipe, to update the recipe. We will try to build a kernel module with Yocto, inside Yocto or outside Yocto. And the last part, maybe the most interested part, is about CI. For example, testing packages or testing the functionality on an image. You can write some scripts to test functionalities. And I will do lots of demos, because when you do demos, you don't speak a lot, so it's okay for everybody. Well, when you have an industrial project, you have some necessary tasks, but costly tasks, such as installing the BSP from Yocto, for example, or Beerroot, or PTXDist, which is the next conference. You have to create the SDK for building apps. It should be done with the same tool. You have to develop your applications, which is your job. Most of the time, nobody wants to sell and to buy a Linux system. It's not interesting at all for the people. They want the system to work and the application to work. And then you have to integrate and maintain the system in the long term. It's strange because it doesn't. Yes. It's not the last version of the slide, I think, but it's not a problem here. So a build system such as Yocto is not a development tool, but it's a tool to generate the SDK, to create the BSP, and to create tools in order to manage the system, the image, and the installed system. And I will show some tool to debug, not debug, but develop inside Yocto. But most of the time, Yocto is not a tool for development; it's a tool for integration, and development is done outside Yocto. But it's still possible, for example, to compile kernel modules or and to test, to remote debug applications inside Yocto. And developing application needs some additional steps, such as CI, to test packages and to test an image for complex systems. So the most tools are Yocto, Beerroot, OpenWRT, PTXDist, etc. But Yocto is the most famous. Today, all the conference they spoke about Yocto, and the next one, except the next one, we will speak about PTXDist. But there are lots of Yocto users around. So Yocto is based on OpenEmbedded. It's a prefix for international system of measures. And the Yocto main concepts are the metadata, the recipes, the extended recipes. So we will create an extended recipes with tools during the conference. The configurations, the classes includes, and the layer which contains the metadata. And for building a recipe, you have to do bitbake my recipe, and it will create a package you can install. So you can integrate the package directly in the image, or you can install the package using a package system such as IPK, RPM, or DEB. My system, as it is a small system, I use IPK. Okay, this is the principle of Yocto with the layers. And you have in yellow, the Yocto layers, and then you have to add the BSP, example for the Raspberry Pi or etc. So if you run, for example, if you want to build a Yocto image for Raspberry Pi, you have to download Yocto, actually the Pocky sources. You have to get the Raspberry Pi hardware layer with the same branch. You have to create a build environment. You have to add the layers, necessary layers. For the first test, the only necessary additional layers is a Meta Raspberry Pi layer. And you define the machine, and you create a very simple image to test the board. Okay? And you put it on an SD card in case of a Raspberry Pi. That's an example of a very simple recipe, a very simple program based on CMake. We can build with a distribution. So I will show the build, for example. I will remove the build to show there is no problem, but I will build it again. Okay, so if you build the recipe, okay. You can see the package created. Okay, with a single binary, which is on the board. I was afraid about the demo, so I put it on the board before. Okay? Well, in Yocto, there is a very interesting feature, which is the BB Happen. With the BB Happen, it's a quite of extension of a recipe. So you start from a BB recipe, and you add a BB Happen with data, for example, patch or etc., or configurations for BusyBox or the Linux kernel or anything you want. And you can generate a different package with different data based on the same initial recipe. So the most famous example is the splash screen. So the standard splash screen provided by Yocto. You update the logo, and you get a new logo, for example, with the Yocto logo or the Raspberry Pi logo based on if you start with the Open Embedded logo. Okay? The first very simple tool is DevShell. DevShell is just a shell you can start from Yocto to modify source code. So, for example, it opens a new terminal. So we will start with a recipe, and so we type bitbake -c DevShell my pack CMake, for example. Okay. You get a new terminal, very small, and you can edit the code, for example. Okay. And you have you don't use bitbake tools, you use the standard tools. So you can, okay. Okay, and you can, for example, you can copy the binary to the board in order to do a small test, for example. Speed. Okay. Oh, yes. No. Yes. Start. Problems are starting. No, it's not 4. It's not 4. It's 3. Yeah. Yes. Yes. So there's a new example modified by simple tool, but it's not that very interesting. But it's a possibility to do a small test. Okay. The next tool, which is much more interesting, is a dev tool. So dev tool is a way to modify recipe, not modify the sources inside Yocto. So you start dev tool on an existing recipe, for example. You can create this recipe with dev tool, but and it will create in another layer. It will create a BB append to, for example, to apply a patch to the initial recipe. But you can do that by hand, for example, if you edit, we create a new layer and you edit, etc. But if you want to do in a simple way, you can use DevTool for that. There are lots of functionalities in DevTool, but this is a very simple example I can do in some minutes here. So for example, instead of dev shell, I use DevTool, not with bitbake, DevTool, modify, okay? Okay. Well, so when it adds a local directory, which is a workspace, which is called workspace, where the dev tool copies the sources of the recipe. And you can add, and it's automatically add the new layer to the BB layer to the list of the layer, okay? So you can go to the workspace, and the main difference is that the sources is managed by Git. So you change the source, DevTool, instead of the shell. You commit the modif. DevTool demo. Okay. And you just have to create a new layer. For example, create layer, meta FOSDEM new. It exists. So I will remove because I want to be honest. Okay. I create a new layer. I add a layer, but it's an empty layer. Okay, 3. First new. Okay, there is nothing except some small example which is not useful for us. And then you can DevTool, finish, mypack cmake, and you just give the path of the new layer. Okay. So it's a bit. It creates everything to create a BB append for the recipe. Okay. So as I said, you have to remove the workspace, which is not this one. It was the wrong line. You remove the workspace because it's not useful anymore. And now you can build the recipe again with bitbake. And you should notice, if it works, that the version of the release will not be upgraded. Okay, but it's not a problem. Yes, because yeah, okay. I forgot something. So you have here, you have the result of the modification. And the best way is the following, is to change the version of the recipe to force it to compile again. So with the package system, you can update the package much more easily. Okay? So you have a new package with the R1 version instead of R0. Okay? With Yocto, you can create, it's a very interesting feature of Yocto, you can create a SDK, which is called extensible SDK. You can install very easily on another PC, Linux system with quite the same distribution. It creates a shell script, which includes the SDK, and you just have to run the shell script to install the cross-compiler. And the SDK is mostly the cross-compiler. Across debugger, you have an Eclipse plugin, Yocto emulator if necessary, and you don't need to know Yocto to use it. And it's very interesting because in most of companies, you have a team integrating and testing the packages with Yocto and system knowledge, and most of people, they don't know anything about Yocto. They build their own system, they build their own programs with their knowledge, and they give the sources. Once tested, they give the sources to the Yocto team to integrate the new version as a package. Okay? So there is a specific documentation in the Yocto documentation about ESDK. The simple way to create the SDK is to use a bitbake mid-title chain, which creates a basic SDK, and you just have to execute the shell script to install the SDK as follows, with sourcing a script which is provided by Yocto. For example, I'm going to do it. It's already installed, so I can do it. So you go to you source the OPT, OK, 3D environment, okay, and so the $CC is modified. So you just okay. It's not a .ko. Okay. Okay. But most of the time, you may have to integrate some specific libraries or scripts or anything you want. For example, when you use a Qt, you have a QMake, you have some script. If you use the Xenomile, the extension, the real-time extension for Linux, you have some tools and specific libraries. So you want to integrate the libraries in the SDK. And for that, to create an image, for example, an image including Xenomile, and you use the populate SDK function to get the SDK, which includes the same libraries as the image. And you can also include the kernel sources if you want to develop kernel modules with the SDK, so you can do everything outside Yocto. Okay, so for example, if you want to compile a module, you do make kernel src equal, etc. And you give the path to the kernel sources used by the board. Okay? For example, with a simple module, it's a kernel, it's still a hello, make kernel src equal /opt poky 3 sysroot arm USR SRC kernel. Okay? And you copy the module to the board. And you load the module, for example, ins mode hello.kio. Okay? So you have the module in the board. There is a functionality to do the same with inside Yocto. And there is a directory which is used for the kernel recipes. If you integrate a module in the kernel in a recipe, but it is in the Yocto directory, not outside the Yocto directory. You can use it from Yocto, but it's not. I think it's not a good way, but you can use it if you want. It's TMP work shared, etc. Kernel build artifacts, exactly the kernel source necessary to compile a module. Okay, so the last part is to try to use some CI functionalities. So when you add functions or you modify a system, you want to check there is no regression on the system after an upgrade on the standard components and on added application you develop with the SDK, and then you add packages, for example. So you have lots of methods and tools for that. It's very famous, and I don't want to talk about it again. And there are two functions provided by Yocto, which is ptest, to test a package, and test image, to test an image. And of course, it's possible to extend. There are lots of examples in Yocto for standard packages such as BusyBox, BlueZ, etc. But you can define your own test for ptest or for test image. Okay, so we try to, for example, for ptest, in the local.conf, you have to add some distro features and image features to include the ptest functionalities. And once you create a specific image with this modification, you have all the package, including the ptest scripts, in the USR, lib, etc. ptest. So my distro is my image use ptest. So for example, you can see there is in USR lib. You have, for example, in BusyBox, you have the ptest for BusyBox, etc. And you have a command to see what are the package, including a ptest script. Like, okay. And you can test a package with a ptest runner command inside on the board or from SSH, which is much easier if you want to have an automatic test. So as an example, we develop a small program which converts Celsius to Fahrenheit, which is very useful. Okay, and we want to check the program is okay. So with the program, we give a script far, not hard, with some a script which is called runptest. It's a simple shell script, and a list of data which is simply temperature in Celsius and temperature in Fahrenheit, and we run the test to see if the program gives the right value for Fahrenheit. So, for example, I do the ptest far. Okay, and you begin the test. So, and you have the result of the test. And of course, you can do that from SSH. And you can do, if you type only ptest runner, you run all the tests. But it's very long, so I will not do this. And another one is a global testing. It's quite different because instead of testing a package on the board, for example, you want to test some functionalities, for example, the network, for example, SSH, and basically it's designed to be run by QEMU, by the QEMU target. But if you configure Yocto, you can make it run on a hardware board already running, for example. But there are several ways to test. You can test a booting target, you can test an already running target, etc. What we will do with a running target is much more simpler. So you, you add an inherit on the test image, and you define the test suite. And there are lots of examples of test suite. For example, on the network with ping, SSH, you can check the size of the disk, the remaining size on the disk. You define the way to test. Already finished? Oh, it's quite finished. And then you can do the test. For example, it's you can do that from the build environment, bitbake -c test image. Yeah. Yes. Okay. You are at English time.
I'm always on time. Oh, sorry, it's my mistake.
Oh, okay. So I will be slower. So you can run from the PC. You can run a bitbake -c test image on the image you want to test, and it will run the test. So, for example, no, I will first try with a standard test. So ping and SSH are standard test. Core, image, minimal. Okay. So of course the board should be. So I modified the local.conf. So there is a small indexing of the packages of the recipe. Sorry. But the most interesting, of course, you can add a new test. The standard tests are in meta layer, lib, OQA, etc. runtime, and you can add your new test in a new layer, and you write the test with the API provided by Yocto. It's a Python, and I just wrote a simple test today to show you. It's a test. We check if the kernel modules are loaded. It's very simple. But first we will test with the standard features. Okay, proof. Okay. Do test image. Okay. So all the two tests are okay. Then I add a new test. For example, I want to be sure that the module is loaded. So my sample module, I want to test on the board, the module is loaded. So I wrote a very simple test which use LSMod and say LSMod size should be more than one line. It's very simple, but well, why not? And the test is here. Meta FOSDEM lib OQR item cases, and it's called LSMod. You know. So this is a very simple test. You run a command from SSH LSMod pipe WC -L, and I check the result is greater than 1. So I have to add the test. And first, if I remove the module, there will be a failure, of course. So sorry for my old PC, it's a bit slow. No, it's not that slow. So there is an error, not because there is an error on Yocto, but because there is an error in the test. Okay, so you can see in in the file. Of course, you can do some additional stuff to that. You will get a message. Okay. You will get the message kernel module is not loaded. Not loaded. Okay. So I insert the module, and I run the test again. And of course, it will work. Okay. Okay. Well. So that's very simple, but you can, if you have some additional components around, you can do some interesting things with some tools, such as test image, ptest, etc. Do you have any question? And you speak slowly, please, in English, or you speak French with a South accent. No, I understand a little bit.
There isn't any way to flash the image after the building process and then test it?
Yes, of course, I think so. Well, the answer is with Yocto you can do anything you want. You just have to write, you can write a class to flash an image and to test the image, and you can combine any tools you want. I don't know if there is, I think there is an existing configuration for test image for that, but I'm not sure. I never used it, but I think there is.
Okay. Thank you.
No more questions? Okay. So thank you.